So last topic will be kinetic molecular model of an ideal gas. So as you can see in the screen, you have four assumptions for this kinetic model. So first, the assumption for this one is a container contains a very large number of identical molecules. Then next is you have the molecules behave like point particles that are small compared to the size of the container and the average distance between molecules. Then third is the molecules are in constant motion and undergo perfectly elastic collision. And then lastly is the container walls are perfectly rigid and do not move. So this is the concept behind the question ganina a while ago on the behavior of the speed of air above the frying pan compared to the air beside or sa kilid sa wall or anywhere inside the kitchen. So kinetic molecular model. So there's a direct relation ay ano tawag ani difference of the movement of each molecule if na ay other molecules na mo interact around them. So use the assumptions to check if valid ba for a kinetic molecular model ang isa ka certain molecule. So example ana is siya. What is the average translational kinetic energy of an ideal gas molecule at 27 degrees Celsius? So what is the total random translational kinetic energy of the molecules in 1 mole of this gas? And lastly is what is the root mean square speed of oxygen molecules at this temperature? So natin bagong mga words na translational kinetic energy. Then you have also the root mean square or RMS speed of oxygen. So naala na siya yung mga formulas na gamiton. So for your translational kinetic energy, use the value in the equation 18.16, that is 1/2 mv squared, which is the average speed. So that is, ang gihatag sa imo is, man, ama na siya gikan ang mga values. So you have the temperature. How did you get the K? So 3/2 times Kp, or the temperature is the coefficient for a kinetic mole gas is 1.38 times 10 raised to negative 23 joules per Kelvin multiplied to the value 27 degrees Celsius. Convert that to Kelvin value. So 27 plus 273, that is equal to 300 Kelvin. So multiply all the values, you'll get the kinetic energy, total random translational kinetic energy of the molecule at 1 mole gas. So 6.21 times 10 raised to negative 21 joules. So it's an energy siya, no? So from equation 18.14, the kinetic energy of 1 mole is just 3/2 nRT. So naatay mole, naatay R, gas constant, and you have the temperature, that is 27 plus 273. So just multiply the values, 3/2 times 1 mole times the temperature. So that is equal to 3740 joules. And lastly, what is the root mean square? So root mean square is just, it is a speed which is equal to the square root of 3 kT over m. So for a gas is 1.38 times 10 raised to negative 23 joules per Kelvin times 3 times the temperature at absolute value, that is 300, divided by the mass of the gas, oxygen gas. So that is equal to 484 meter per second, or equal to 1,080 miles per hour. So, pwede na ng 484 meters per second. So, you are also, pwede na po na gamiton ang RMS or the root mean square na pag-solve using the square root of 3RT over M, or the molar mass, that is 32 times 10 raised to negative 3 kilograms per mole, and then the gas constant is 8.314 joules per k-mole. So, same result na result, that is 484 meter per second. But you usually kani itong ginagamit no na formula. Yan siya. The square root of 3RT over M. So, question. So, next is calculating RMS and average speeds. So, 5 gas molecules chosen at random are found to have speeds of 500, 600, 700, 800, and 900 meter per second. What is the RMS speed? What is the average speed? So, you get the average speed of the average speed of those given speeds. So that is equal to 500 square plus 600 square down to 900 square divided by 5, that is 5 variables. So that is equal to your v squared is 5.10 raised times 10 raised to negative 5 times 10 raised to 5 meters squared per second squared. That is your average v squared. So to get the RMS, so square root lang sa value, so that is 714 meter per second. So you can also use the katong average diretso na i-add lang tanan ang 500 down to 900 divided by 5, ang imong result is 700. So your average speed is not equal to your RMS speed. So mas kuan siya, nganong di man siya magparehas. Ang average speed lang is you get the average of those values, while your kaning RMS nimo is lahi iyahang way, so mas bugat iyahang iyahang value, so mas accurate siya in terms sa pag-compute sa imuhang speed of certain molecules. Question. Wala. So let's proceed. So collision. So collision is we model molecules as rigid spheres of radius r as shown at the right. So there are may tendencies na si molecule, which is siya, assumed to be spherical at shape, na possible niya na magbangga-bangga siya. So there is nagtawag na mean free path of a molecule, which is the average distance it travels between collision. So the average time between collision is the mean free time, and then let's check the derivation. So kaniyang mean free path and then the time. So first is estimate the mean free path of a molecule of air at 27 degrees Celsius and 180 m. So model the molecules as spheres with the radius equal to 2 times 10 raised to negative 10 meter. And then estimate the mean free time of an oxygen molecule with V velocity is equal, or speed is equal to the RMS speed at 27 degrees Celsius and 180 m. So pangitaon na nato ang mean free path, or equal to lambda equals kT over 4 pi the square root of 2 r squared p, or the pressure. So, sa man na, ang na values nato, naatay temperature, naatay K, naatay pi, which is given ng pi, tapos naatay R, naatay pressure. So, direct substitution lang sa mga given data. So, 27 degrees, convert this to 27 degrees, convert that to Kelvin, that is 27 plus 273, that is 300. So, given ang K, constant na siya, and then your R squared is gikan na siya diri sa radius nimo 2 times 10 raised to negative 10 meter. That is the radius of the sphere. And then your pressure is 1 atm or equal to 1.01 times 10 raised to 5 Pascal. So your mean free path sa molecule of air is 5.8 times 10 raised to negative 8. So unsa pasabot ana, that is the measurement sa pasabot sa mean free path. Molecule is the average distance it travel between collision. So kung mag-collide siya or magbangga ang katong certain molecules of oxygen, kung there is a example, or kaning air, ang iyahang direction or iyahang katas-unon sa iyahang after pag-collide is 5.8 times 10 raised to negative 8 meter. So muna siya yung bangga, kumbaga. Then next is estimate the mean free time on the oxygen molecule with assumption nato is ang speed is average speed is equal to the RMS speed. So wait lang for a while. Next is the mean free time of oxygen molecule na nag-assume ta na iyang speed is equal to the RMS speed at 27 degrees Celsius and then 1 atm. So ang mean free time is just equal to the lambda or the mean free path divided by the velocity or the average velocity of the molecule. So ganina na-compute mo nato sa tong first example nato na ang speed, RMS speed ni oxygen, kani dire, oxygen na ito ipakita, that's equal to 484. Muna siyang RMS niya or the root mean square speed of an oxygen na molecule. So muna siya itong gamiton dire, 484 meter per second squared. Your lambda or your mean free path is, kani siya na-calculate na to dire, that is equal to 5.8 times 10 raised to negative 8 meter. So you just divide the mean free path divided by the velocity, which is assumed to be the RMS velocity also. So equal to 1.2 times 10 raised to negative 10 seconds. So this molecule undergoes about 10 raised to 10 collisions per second. So muna siya yung pagkasabutan na iyang pag kung imo na siyang i-explain further. So na ay 10 raised to 10 collisions per second nga kitabo sa oxygen molecule. Question.